I spent the last few videos talking about compression without actually showing a compressor. So now I'm going to go ahead and show you one. This is a stock plug-in compressor in Logic Pro, but you'll see similar interfaces for other compressors regardless of whether they're software, plugins, or external hardware. You can see there are a few different knobs, including the ones we talked about previously, threshold and ratio. There's also makeup gain, which I mentioned in my What is Compression video. You can use makeup gain to increase the volume of the audio after it has been compressed. I don't recommend using auto gain, and as you can see here, I have it turned off. The other knobs are knee, attack, and release. These settings will also affect how the compressor applies compression. And so I have set these to their lowest settings so we can just focus on threshold and ratio. On the left side, you can see it shows your input levels. Once audio is coming in, you'll actually see this going up and down. And then on the right side, you can see the outgoing level. So everything coming out of the compressor, you'll see the levels of that. You can monitor the compressor's behavior using a graph or meter, and you can toggle between these as well. So these both show the compressor working in real time. Once there's actually audio playing, you'll see this needle moving, and that needle represents the amount of gain reduction applied to the audio signal. I find the graph to be helpful in understanding what the compressor plans to do with the audio, so I'm going to play with that and show you. Right now the graph is empty, and the reason why is because I had the ratio set really high. So I'm going to go ahead and set the ratio back to 1:1, so now you can see that there's a line on this graph. The x-axis of this graph represents the loudness of the signal coming into the compressor, and the y-axis represents the loudness after the signal is compressed. When I turn the threshold and ratio knobs, this line will change. So going back to something I mentioned in a previous video, an important thing to note is that typically the compressor will not operate if the ratio is set to 1:1. A 1:1 ratio simply means that input will equal output. So for every 1 decibel that exceeds the threshold, 1 decibel will be allowed to exceed the threshold. So nothing happens, nothing changes. No matter what your threshold's set to, there will be no compression at a 1:1 ratio. Similarly, if your threshold is set to 0, typically the compressor will not operate either, no matter how high your ratio setting is. I can turn this knob as much as I want, and you can see it's still set at a 1:1 ratio, even though the ratio now is at 30:1. There won't be any audio that exceeds the threshold because it's maxed out, and so the compressor won't be triggered. So remember that. If your threshold is set to 0, the compressor won't work no matter what your ratio is. And if your ratio is set to 1:1, the compressor won't work regardless of what your threshold is. Once I set the threshold below 0, you can start seeing this line change. So what I'm going to do, this line here. So what I'm going to do is I'm going to set the ratio to 2:1, and you can see now that the line has changed. I've set the threshold to 40 decibels. Looking at the graph, you can see how much gain reduction you're going to get. If the incoming audio is at minus 10 decibels, it will be compressed down to minus 25 decibels, which is a gain reduction of minus 15 decibels. If the incoming audio is louder, say minus 20 decibels, it'll be compressed to minus 30 decibels, which is a gain reduction of minus 10. The louder signal will be compressed more. A signal at minus 10 will lose 15 decibels, while a signal at minus 20 will lose only 10 decibels. When I remove the ratio, you can see the line change in a way I had described in the previous video. So the larger the ratio, the lower this line will get. You see this line going down, which means more compression is being applied. So in this case, at 2, you've got a minus 10 that turns into minus 25. But if I increase that compression, say 8:1, now my minus 10 is turning into something that looks like maybe minus 36, minus 37 dB. And as I turn this knob even more, it gets more and more compressed. If I increase the threshold, I'm going to put this back at a 2:1. If I increase the threshold, you can see that I start to get two lines at an angle where everything under the threshold is a 1-to-1 ratio, and that will not be compressed. And everything over the ratio, let me increase the compression so you can really see the difference between those two lines. Everything over that ratio is now going to be compressed. Once you set the ratio really, really high, you start to get a flat line. This is essentially a limiter. Once your ratio gets above about 20-to-1, you've now created almost like a brick wall that shuts down any audio that exceeds the threshold. So as you can see, this is 1-to-1. There's no compression on anything that's less than, this probably looks like minus 23 decibels. So anything under minus 23 is not going to get touched. But the minute you cross that line, say you're at 10, if your incoming signal is minus 10, it's going to come out at what this threshold is set at, which, just to make the number even, I'm going to set it at 20. So a signal at, minus 5, which is pretty loud, gets slammed down to minus 20. Similarly, a signal at minus 10 gets slammed down to minus 20. And a signal coming in at minus 20 is going to stay minus 20. And anything underneath that is also going to remain the same. Everything above that is just going to get completely pummeled. So that is effectively a limiter.